Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve the questions on series resonance circuit from IES, EC, EEE and GATE examinations. Friends, first let us solve question 1 in which we are required to find the value of C if current through 50 ohm resistance is 0. This is the important information given. Please note. Further, the supply voltage given is V is equal to 5 pi sine 5000 t. From this equation, we get omega is equal to 5000 radians per second. Observe the network. It has only two junction nodes. So, to solve the network, let us assume one junction node voltage as V1. By writing the nodal equation for node V1, we get V1 divided by j omega L plus V1 divided by j omega L minus j 1 upon omega C is equal to 0. Note, current through 50 ohm resistance branch is 0. From the equation, we get 1 divided by omega L plus 1 divided by omega L minus 1 upon omega C is equal to 0. By substituting for omega and L and solving for C, we get C is equal to 20 microfarads. Friends, according to me, this problem is easy and interesting too. The given data is resonant frequency F0 is equal to 1.5 kilohertz. Power consumed at resonance frequency is 100 watt. Source voltage V is equal to 100 volts and bandwidth is equal to 0.75 kilohertz. We are required to find R, L and Q. We know power is consumed only in resistance. Knowing V and power consumed P, we know P is equal to V square divided by R. So, R is equal to V square divided by P. By substituting the values of V and P and solving, we get R is equal to 100 ohm. To find Q, we know Q is equal to F0 divided by bandwidth. By substituting the values and solving, we get Q is equal to 2. Further, to find L, we know Q is equal to omega naught L divided by R, from which we get L is equal to Q into R divided by omega naught. But we know omega naught is equal to 2 pi F naught. So, by substituting the values and solving and rearranging, we get L is equal to 0.2 divided by 3 pi henries. Finally, we got R is equal to 100 ohm, L is equal to 0.2 divided by 3 pi henries and Q is equal to 2. Hence, option A is the correct answer. Friends, next, we shall solve one simple problem. The data given is resonance frequency F0 is equal to 1.5 megahertz. Capacitance at resonance C is equal to 150 picofarads and bandwidth is equal to 10 kilohertz. We are required to find the value of R. We know bandwidth is equal to F0 by Q, and by substituting the values and solving, we get Q is equal to 150. Once you know Q, you must start thinking about the equation for Q is equal to omega naught L by R, but we don't know L. So let us use Q is equal to 1 divided by omega naught CR, as we know C at resonance, from which we get R is equal to 1 divided by Q into omega naught into C. By substituting the values and solving, we get R is equal to 4.7 ohm. Hence, option D is the correct answer. Very easy, isn't it? Friends, this problem is simple but tricky in my opinion. Read the problem statement. A 20 ohm resistance is connected in series with a coil and a capacitance across a 25 volt supply. And we are required to find the resistance and the inductance of the coil. What does this mean? In addition to 20 ohm resistance, the coil resistance also is present. Based on this statement, the circuit drawn is shown in figure. Let R is equal to 20 ohm and the resistance of the coil be RL. Then total resistance of the circuit RT is equal to 20 plus RL ohm. But we know at resonance, the impedance of the circuit will be purely resistive. So, Z0 is equal to RT and that is equal to 20 plus RL ohm. Also, we know RT is equal to phi divided by I naught. By substituting the values, we get RT is equal to 50 ohm. So, substituting this value of RT, we get RL is equal to 30 ohm. To find L, there are options like Q is equal to 1 upon R into square root of L by C, but here L and C are unknown. Q is equal to omega naught L divided by R, but Q and L are unknown. F naught is equal to 1 divided by 2 pi root LC, but L and C are unknown. So, we need to think out of the box and find the capacitance value C first. We know voltage across C at resonance is 150 volts and let phi naught C is equal to 150 volts. But phi naught C is equal to I naught into X naught C, where X naught C is the capacitive reactance at resonance. By substituting the values and solving, we get X naught C is equal to 300 ohm. Using X naught C is equal to 1 divided by 2 pi F naught C, substituting the values and solving, we get C is equal to 1.326 microfarads. Finally, using F naught is equal to 1 divided by 2 pi root LC, we get L is equal to 1 divided by 4 pi square F naught square C. Substituting the values and solving, we get L is equal to 0.12 henries. Friends, finally, we shall solve question 5. It's very easy. Based on the problem statement, the circuit diagram drawn is shown in figure. You find that there are two coils, one of R1 and L1 and the other of R2 and L2, and two capacitors, one of C1 and the other of C2, and one more resistance R3, all are connected in series across a 10 volt supply. We are required to find the resonance frequency, Q of the coils, and Q of the entire circuit, and finally power dissipated at resonance. To find the resonance frequency and quality factors, we need to find the total resistance RT, total inductance LT, and the total capacitance CT. We know RT is equal to R1 plus R2 plus R3. By substituting the values and solving, we get RT is equal to 2 ohm. Note that inductances are magnetically not coupled. Hence, LT is equal to L1 plus L2. So, by substituting the values and solving, we get LT is equal to 50 millihenries. Similarly, Ct is equal to C1 into C2 divided by C1 plus C2. By substituting the values and solving, we get Ct is equal to 15 microfarads. Friends, the circuit drawn indicating the values of RT, LT and CT obtained is shown here. To find omega naught, we know omega naught is equal to 1 divided by square root of LT into CT. By substituting the values and solving, we get omega naught is equal to 1154.7 radians per second. To find the Q of the coils, the given values of L1, R1, L2, R2 are reproduced here. We know Q1 is equal to omega naught L1 divided by R1. By substituting the values and solving, we get Q1 is equal to 73.9. Similarly, Q2 is equal to omega naught into L2 divided by R2. By substituting the values and solving, we get Q2 is equal to 15.988. And Q of the entire circuit, Q is equal to omega naught into LT divided by RT. By substituting the values and solving, we get Q is equal to 28.86. Finally, we know power absorbed P is equal to V square divided by RT. By substituting the values and solving, we get P is equal to 50 watts. Very interesting and simple, isn't it? Friends, during this tutorial, we solved few interesting problems. We shall meet during the next tutorial and solve some more typical problems of IES, GATE, EC and EE of the topic on network solving. Thank you for watching.